All right, welcome to week 15, video 3, where we're going to talk about cross sections. So cross sections just basically mean what happens when you slice a shape, right? So I made some Play-Doh for this video. So if you end up finding this very interesting and you want to try to do this at your own house, let me know and I'll post the recipe that I used for the Play-Doh. But a cross section basically says if you cut the shape, that is the cross section, and it forms, when you cut it, it forms another shape on the inside of it, right? So we have a rectangular prism, but when we do a cross section, and here we did it diagonally, we end up getting a 2D shape, right? That is like that. So we're going to go through all of our 5 different 3D shapes. Sometimes they're also called 3D solids, and talk about what happens when you slice them in different ways. We're going to talk about the similarities between all the different shapes and what different unique situations can come up with. You will have 2 Khan Academy exercises about cross sections, so let's get going. So let's return to our rectangular prism. So I already have these pre-sliced because I recorded this video and then the file got corrupted somehow. So I'm redoing it, sort of, kind of. So we have our rectangular prism. We have 3 ways we can do cross sections. We can do parallel with the base, so kind of like you're cutting it to make like cake layers, or you're cutting a hamburger bun or a hot dog bun so you can put something inside. We can then cut perpendicular with the base, so kind of like, you're slicing a vegetable to cook, or you're doing bread slices, right? Or we can cut diagonally, we can cut diagonally with the base, or diagonally with the base. So diagonal has a couple different times, and that's when we're going to get a lot more unique situations. So let's start off. We're going to pretend to cut parallel with the base, right? We have a rectangular prism, so when we open it up, we also get a rectangle. So we're going to notice in all of our shapes, when we do a parallel cross section, the cross section is going to be the same shape as the base. There'll be some differences when we get to other shapes, but the base and the cross section are the exact same shape for a prism. All right, let's do perpendicular next, right? So let's do a cross section perpendicular to the base, right? And we open it up. For this specific prism, we end up getting a square. All right. Maybe we'll end up getting that with everything else. Maybe we can look at, during other times, different prisms, like a triangular prism or a pentagonal prism. But I just did rectangular prism because it was the easiest to make. Next up, we could do diagonal, right? We're going to slice through it diagonally, right, with the base, and we end up getting a rectangle instead of a square. So those are the examples. Those are the ones that we probably predict. But I have a weird example here. All right, we're going to cut diagonally, but instead of cutting diagonally like this, we're going to put it at a slight slant. So we're going to cut diagonally, and when we do that, we end up getting a triangle. So there is a way to slice a rectangular prism to end up getting a triangle. All right, so fun stuff can happen. We really have to wrap our heads around it, try to imagine the 3D solid in our heads, and imagine actually getting sliced, because the Khan Academy pictures aren't too, like, you can't move them around or anything like that. They're not like 3D models. So make sure that we imagine what these things are and really think about it. So then the next polyhedra that we have is our pyramid. So here we have a square a square-based pyramid. All right, and we're going to always start off with doing parallel cuts. So if I do our parallel cross-section, right, we had a square-based pyramid, and we end up getting a square cross-section. But notice how, if we compare the base, the original base to the cross-section is a lot smaller. And that makes sense, right? Because we're going further up in the pyramid, and we're getting smaller as we get up to the vertex. This shape has been around for a lot, right? So pyramids, right? The ancient Egyptians built pyramids along with the Aztec and the Mayan, and just a lot of different cultures built pyramids because that's kind of how stuff piles up. But we actually have a word for this shape, right? If we cut the top off a pyramid, it's called a truncated pyramid. And we can see it kind of looks like we have trapezoids on the sides. But that is a different shape that we're not going to talk about. But I did want you to hear the name of it. Again, truncated pyramid is what we get when we cut off the top. Right, this is truncated. This is what the Egyptians built before they built the Great Pyramids on Giza. Truncated pyramids. Next up, let's try to see what happens when we cut perpendicular. All right. So here you can kind of see I already did this video and had to repeat it, so I apologize. It's not brand new for you. But we have this pyramid, and we're going to cut it perpendicular through the vertex, through the very top, and we end up getting a nice triangle as the cross-section, right? Makes sense. Pyramid looks like a triangle. But an interesting thing can happen is if we still cut perpendicular, but not through the vertex. So we're slicing it very carefully so not to add pressure. We can't see it too well on this one, but we can see it better over here. When we cut just perpendicular but not through the vertex, we end up getting a beautiful trapezoid as a cross-section. You kind of see here, right? Here's the top of it. So here's our trapezoids. So when we're reading the Khan Academy, we have to pay close attention to it says a perpendicular cross-section through the vertex. A perpendicular cross-section not through the vertex. Or another example would be a cross-section diagonally, right? So here we have our still a square-based pyramid. Just trying to make it more square. And then let's try to cut it, slice it diagonally through the vertex. So we're also going through those edges, right? So if we do that, we get another triangle. But if we compare it to the other triangle that we got when we cut perpendicularly, this one is actually a little bit wider. The same height, just wider. All right? But, right, we just get a triangle when we cut a pyramid diagonally through the vertex. But what happens if we cut it not through the vertex? All right? So here we get another triangle. So nothing too crazy here, right? It's definitely smaller because we're getting further away from the total height, but nothing too weird or something that we can't wrap our head around. So use this to help you on your Khan Academy. Use it to reference back to, or use it as inspiration to try to make some Play-Doh on your stovetop like I did, just with some flour, salt, and oil and water. And you can actually make the shape that Khan Academy is asking about. So here we have a cone. The cone was the hardest for me to make with my own Play-Doh, just because it's a weird shape. So let's cut it parallel to the base. All right. We've said by now the pattern is if we cut parallel to the base, we're going to get the same shape as the base. So here we get, right, the base of a cone is circular. Here's the base of the cone, and here's our cross-section. It's smaller because just like the pyramid, when we go up, right, the cone gets smaller too. All right. So let's talk about perpendicular. All right, so here we have our cone. I'm just trying to make it not so squished. All right, so let's cut perpendicularly through the vertex of the cone. The cone has some weird stuff with it. When you're in pre-calc, you actually have a whole unit about what happens when you do cross-sections of cones. And with this, we get a triangle. So no curves at all when we cut through a cone through the vertex. All right. we get a triangle. So let's put our cone back together. But what happens if we cut perpendicularly, not through the vertex, so off to the side, right? So we end up getting, and it's hard to see on this side, but we end up getting not a triangle, but we have a flat side on the bottom, and then this curve right here, right? Kind of like a parabola. That would be, we don't have a name for this. Maybe you would want to call it an arch or anything like that. But it's just a flat side and then a curved side, all right? So that's what happens when we cut perpendicularly. Here's an example for what we get when we cut diagonally, and diagonally like this, right? So let's cut, I'm gonna cut it, and then I'm gonna end up hitting the base and cutting and ending on the base, all right? So when we do that, we end up getting a similar shape, right? Flat on the bottom, curved on the top. But what happens if I cut diagonally further up and I don't hit the base, right? So I slice through the cone, I end up getting, right, an oval. In math, we also call that an ellipse, right? So we can, if we cut diagonally through a cone, we get not a circle, but instead we get an elongated circle, which is an oval, aka an ellipse. All right, so we have two more shapes to worry about. Here we have a cone. We cut parallel, right? We end up getting, no surprise, the same shape as the base, and it's the same exact size as well because our cone is the same size all the way through, right? So let's worry about what happens when we cut perpendicular. All right, just squaring up the sides, making it look like a good cone. So let's cut perpendicularly through the thickest part of this cylinder, and we end up getting, I don't know if you can see it too well, but we end up actually getting a rectangle, right? So if we cut perpendicular to the base, we end up getting a rectangle from a cylinder. Let's see if that's only at the center or if that's all the slices perpendicularly. So let's cut through it carefully, and again, we get a rectangle as well. Smaller, but we still get a rectangle. Last way we're going to cut our cylinder is by cutting diagonally. All right, so cut diagonally, and we end up getting, again, just like we did with the cone, we got an ellipse or an oval, depending on which you want to call it. All right, the last shape we have to talk about, our last solid, is a sphere. All right, spheres don't have too many interesting things about it, no matter how we slice it. Right, if we cut through the thickest part of our sphere, right, along the equator, right, along a longitude, we end up getting a circle, right? If we cut not through the equator, if we just cut further off, we end up getting still a circle. Just got squished by me. Still a circle, but it's smaller. So with the sphere, we'll always get a circle, just different sizes. So hopefully this helps you when you work on the Khan Academy. If you want, we can come back. This Play-Doh will be good. The recipe set for a couple months. So you can come back to me during seminar, during morning support hours, or during class, and we can make different shapes and talk about what cross sections we get. Good luck.